Right, so this is the first lesson in this unit, something that is kind of new. You would have done a little bit of this in grade 9. So our goal today is to determine the area of composite figures. Now, when we're talking about a composite figure, we know that it is a figure, it's two-dimensional, that is made up of more than one simple figure. And so we've already reviewed the simple figures, so now it's just putting them together. Now, the following are possible steps. Again, it depends on what the composite figure is made of, whether these steps work exactly it's as 1, 2, 3, 4, 5. Okay, first of all, make sure that you break the figure into simpler figures, ones that you know how to calculate. If you don't know how to calculate them, then there's no sense you breaking it into that smaller shape. Then what you need to do is you need to calculate the area of each part, and you're either going to add areas, and it's possible that you might have to subtract some areas from the figure. Okay, so let's try looking at our first example. Okay, here's our first example, and you can see that it is made up of more than one shape. And you also can see in the right-hand corner, I also have our formula sheet. So remember, you're not expected to memorize these formulas. They will be given to you. However, you have to determine what formulas you need. You can see if we examine the shape, we have at the top a parallelogram. This shape here is a rectangle. And finally, you can see that we have half of a circle that's been removed from it. It's almost been eaten out of the rectangle. So those are our three simple shapes. And what we're going to do with those shapes, because they're asked us to find the shaded area, is obviously we're going to add the parallelogram, the rectangle, and the circle. So the first thing I'm going to do is I am actually going to label those shapes so that I have them labeled in my solution. So the parallelogram, as soon as I get my pen working, I'm going to call shape 1. My rectangle I'm going to call shape 2. And finally, my circle, half circle, I'm going to call shape 3. So we know that add 1 and 2, and then we're going to subtract 3. So that's what I'm going to do first. I'm going to tell the person that is in my solution that I am going to go 1, 2, subtract 3. And I'm literally going to label it on my diagram as well. Okay, so this, what I'm writing down, is our solution. Okay, the first shape you can see, as we talked about, is parallelogram. So then what we do is we go to our formula sheet, and because we're after area, we want to make sure that we're down in the area column, and we go across to our parallelogram. Now here, when they're talking about height, they're talking about perpendicular height. If we go back to our diagram, you can see that we are given the perpendicular height. So that's important to see what each variable stands for in our formulas. So I'm going to put that back up here. And so now what we're going to do is we're actually going to start. So just to make my solution again a little more attractive to someone else watching, I'm literally going to put area equals. And down below, I am going to put the formulas. So base times height, the perpendicular height for our parallelogram. Our rectangle is length times width. And finally, we want half of a circle. Okay, so we want half of, and the circle is pi r squared. So now it's a matter of filling in what we know. Okay, our base of our parallelogram is this distance here. I have to look in the diagram to find that actually that's 16 inches. So we're going to put 16. And our perpendicular height is 9 inches. And yes, I did check to make sure that I'm all in the same units. My length of my rectangle and width, so 24 and 3/4. Now I would probably change that to a decimal right away, so 24.75, and I'm going to multiply that by 16. And finally, our half circle. Now they gave me the diameter, so I want the radius, so I'm going to divide that by 2, so that's going to be 8 squared. So after that's done, it's just a matter of calculating with my calculator. Now, through the magic of video, I have taken the liberty to calculate this ahead of time, and so now I have what each one of those calculates to, and then again add the first two, subtract the last one, and I end up with 439.47, and we are in inches, so it will be inches squared. Okay, make sure you put units in order for communication marks. Okay, let's go on to our second question. Our second question again also appears to have three shapes. Some of the shapes are different, however, but let's take a closer look. Again, you can see that we have half a circle. Okay, so we have half a circle going on here. And then this shape here, this shape is actually a trapezoid. Okay, so it's a trapezoid. And although I could divide it into a square maybe and a triangle, that would be a lot of extra work. And finally, I have another trapezoid, this larger shape is also a trapezoid. So what I'm going to do is I'm going to actually look at my formula sheet. Do I know how to calculate area of a trapezoid? Well, if I look down my figures, I can see trapezoid. Okay, now watch the trapezoid. Its formula is a little bit different, and it's a little bit harder to see on the video, but you can see it's a plus b. So you have to determine in the diagram that they give you for the formula as well as for your simple shape what a and b are. And again, we need perpendicular height for that as well. So we can see that we have three shapes. So just like the previous question, we're going to label our shapes with numbers from our diagram. So this time I'll use green. So I have a shape 1, shape 2, and shape 3. And in this case, I'm going to add all three shapes. So I'm not subtracting anything. So I end up with area equals 1 plus 2 plus 3. Like the previous question, again, I'm going to write down the simple formulas. So it's going to be 1/2 pi r squared, so that's half my circle. My trapezoid is 1/2 bracket a plus b times height. And I have to repeat that because both of those are trapezoids, and so then I'm going to put it as well. I just have to be careful when I substitute in that I'm substituting the correct a and b and height for the correct trapezoid. Okay, so now it's a matter, again, of substituting things in. Like the previous question, they gave me the diameter. You can see the diameter over here is 3.8, so I need to divide that by 2. And you can either put that in here as being divided by 2 if you want. And I think I will do that since I'm not going to take the time and write it down on the diagram. And also substitute these A's and B's in. So 4.3 plus, make sure it's a plus and not a multiplying, 3.5, multiply it by the height, which is perpendicular height. So now I'm going back. Okay, the height of this, the height of it is here, and that height is 3.8. Now I ran out of room on this line, so I'm just going to pick up this and move it over a little bit for us. Oops. Obviously I should have maybe grouped it, which I didn't do. But I think I can still get it over here. And finally, we'll add the last part. So it's 1/2 a plus b. This time a plus b, 4.1 and 8.2. And obviously I still didn't make that small enough in order to get what I want. And now I've wrecked it, but that's fine. I'll just group this quickly, bring it down here where I have more room. Back to our green again. And we have 4.1 plus 8.2. And again, I have to go looking for the perpendicular height. And you can see that gave it to us on the sides. It's 12.8. Okay, finally what I'm going to do is I'm going to do each one of the calculations, add them together. Now again, when someone is marking something like this, we're after the form, so I'm after you putting a plus b or 1 plus 2 plus 3 formulas, substitute the numbers in so that we can see that you get that aspect of it. As far as the calculations go, you either know how to use your calculator or you don't. Obviously, it doesn't take tons of thinking to use a calculator, so there, mark-wise, that's not as important as the process that you're showing me. And finally, add those three numbers together and you end up with 99.21, and it is meters squared. Okay, good luck with yours.